share screen. And oh, there we go. How's that? Can you see it all right?
Yes.
So anyway, when Tom kind of strong-armed me a little bit to do a presentation, I thought, well, what might be interesting? And well, what's been interesting to me has been my little whisper station. And so I've got little information about that and how I put it together, and also some test equipment that I've recently acquired and that been working out pretty good for me that others might be interested in. All I have to do is figure out how to make this. Well, so probably all of you know that WSPR stands for Weak Signal Propagation Reporter. And it's been around for a few years. But what you might not know is that the message that's contained is only got a few bits of information. It's your call sign, your grid locator, and your power in dBm. It's a very narrow signal, 6 hertz wide, and it uses FSK, frequency shift keying. And the bottom line is that the baud rate is 1.46 baud. So that is super, super low. The data is encoded, which reduces the number of bits, and it also uses forward error correction. The transmissions, if you've got a WSPR station, they start at the beginning of every even numbered minute. So in my particular setup, it starts at 2 minutes past the hour. The transmission lasts for about 2 minutes, and then it just sits there for 10 minutes and can receive. And then after that 10 minutes, it starts up again. The signals that can be received are really down in the noise level. They say that it can receive 28 dB below the noise. And the whole WSPR band that you would be looking at if on the receive end is only 200 hertz wide. Obviously, if you've got a receiver, you can, using the WSPR program or the WSJX, JTX software, you can upload that to a master database, and then you can see, you know, what's been received. So here's just a screenshot of my station, what it received over a short period of time, and that's on the 30-meter band. Here's my setup. The whole station is built around this QRP Labs Ultimate 3S kit. And I actually splurged the $25 and bought the fancy case, which came from China in 2 weeks' time, which I was very surprised. But anyway, in fact, I'm going to show you a couple of QRP Labs things today. I've been very, very pleased with the actual product that this guy's put out. start out with the power supply. I was initially going to run 5 watts because I thought, well, anything under 5 watts certainly isn't going to get out. So I built a power supply out of junk parts I had, and I needed 12 volts for the 5-watt amp, and I needed 5 volts for everything else. And had one of those little dollar DV voltmeters. So I put one of those in, and the 12 the 12 volts. I use an LM338 regulator, and the little perf board that you see there, that's the adjustment circuitry for the 12 volts, and then that'll give you 5 amps at 12 volts. And then I used an LM317, which is an amp and a half for the 5 volts. Here's a little closer shot of the QRP Labs front end. That's a 2-line LCD display. There's the back end. Has a nice DB9 connector, and I actually run the output of that to GPS. There's the inside of the cabinet. It all kind of mounts. I don't want to say oddly, but you can see here. This is your up here. This is your LCD. This is your main board. This board here has got an SI5351 programmable oscillator. And then this little board here, this is your low pass filter that takes the square wave and turns it into a sine wave. Here's the display and the main board. This is the main micro. It's a ATM micro that is used. And then here's the whole business, not mounted in the case, but on the top here, this is your SI5351, and that's that little chip right there. This is your main board. Your low pass filter mounts across these 2 connectors here, and then the LCD board down here. Here it is from a different angle. It goes together real nice. The boards are well made. And oh, this is the power FET right here. So it's just a little FET that's used to generate the output. Now, the radio will actually generate a signal from about 3.5 kilohertz up to about 290 megahertz. But the output in any case is a square wave, and you have to put the output through a low pass filter. Well, he sells a low pass filter board that allows you to actually have 6 different low pass filters, which you can switch in depending upon which frequency that you want to use. And so I'm showing that here. It mounts on these plastic standoffs. I opted in the end not to use this. I decided I was going to use it for something else, which I'll get to. in a few minutes. And so I just have it set up for 30 meters. The GPS module I also bought from QRP Labs. This is my little homemade cabinet. The green light on the left will blink at a 1 second rate when you are successfully receiving your GPS signal and decoding it. Here's the inside. This is the board that you get, and it goes together in about 20 minutes. There's not much in the way of components. It does come with an antenna, which would mount on the other side, but I needed to use an external antenna, so I mounted a connector there for an external antenna. For the watt meter, I've got one of these little MFJs, and I got to tell you that it really is reasonably accurate. Here it's showing 0.2 watts output at 30 meters. And if I monkey with my antenna tuner and get it off resonance, then the reflected power comes up as well. I had a little trouble with my antenna, which I'll get to in a minute. So I needed to build something to get my standing wave down. And I rooted through my junk box and built this little tuner. I didn't have enough sheet metal or plexiglass at the time, and so I didn't make it wide enough, and as a consequence I don't have any room for some dial indicators there, but it perhaps I will remedy that down the road. I set it up so that I can use 2 antennas, and here's the inside. That coil, the air coil, came out of about a 40-year-old antenna tuner that I had laying around that got zapped by lightning. Couple of 6-position rotary switches, and then those are broadcast capacitors, about 360 picofarads a piece, and it actually tunes very, very nicely. The only tricky part was kind of getting the tap on the air coil correct. Now, I might wonder what that is. That is a 50 ohm, 50 watt non-inductive resistor. And I didn't know these things existed. But I wanted to put a little dummy load in this tuner. And so I needed to find a 50 ohm resistor, and I came across this style, and they're really kind of neat. I think it was like $2 for or something. Anyway, if you're looking for, they make them up to a couple hundred watts. Obviously you have to put it on a heat sink of some sort. Now, it's an FSK signal, so technically, if you look at the output of your transmitter, you should be able to see some FSK action. But this is what I get when I look at the output of the transmitter. It's I can't see any FSK action. I monkeyed with the controls, and I think that's because it's so slow. Just is not able to. But if you Google around for whisper type information, there's some oscillograms out there that show the FSK action, but I couldn't get it to do that. Now, I needed an antenna, and 30 meters is kind of my band of interest these days. So I thought, well, what can I do? And I decided, well, I'll cut an antenna for 30 meters and I'll string it around my deck. And so I used one of these one-to-one balons from LDG, and that's just cheap RG8 that goes into my shack, and that's number 12 electrical wire. And you can see it's strung around my deck railing. Highest point is about 12 feet off the ground, and I've got one end at about, I don't know, 10 feet and another end at about 8 feet. So it's not a, it's not a great antenna. So you might wonder, well, okay, he's got the transmitter with that little FET and this crummy antenna. What can it do? Well, here's a report, and you can see that 0.2 of a watt gets out to all coasts in the U.S. and the Canary Islands and to Europe. Here's another showing made it over to Hawaii. This is a typical 1 hour span during the daytime. And the one thing I want to point out on this slide is that notice that none of the adjacent states are receiving the signal. In fact, I have yet to get a reception report from the Dakotas, Iowa, Wisconsin. None of those states. There's a guy down in Costa Rica that receives my signal periodically, and I've been received by this one station in the Antarctica a number of times, and notice it's just very weird the way the whole thing, the way the signal propagates. So here are a couple of observations I've made. First off, and I don't understand why this is, but the angle evidently has a low angle of radiation, because it gets into Europe almost every day. It gets to Hawaii, up to Alaska, but it does not behave as a NVIS antenna. No reports whatsoever from the adjacent states. So I just kind of marvel at that. Now, this is only for 30 meters, so I don't know. I don't know what to say about that, except that I'm investigating that, and I think I'll try maybe 40 meters for a while and see what I get. Anyway, that's my whisper station. Any questions? Can you still hear me? Okay.
Yes, I hear you.
Okay. All right. Well, I'm gonna push on then, and if there are no questions about it, I can recommend the QRP Labs stuff. It's been good kits as far as I've been concerned. One of the things I've been doing lately is messing around more with RF circuits, and I've had for years a Sencor Z meter for checking capacitors and coils, but it was getting really old, almost 40 years old, and it wasn't reading, low values well at all. So I took a chance and bought one of these Chinese LCR meters. And I got to tell you, I've been really impressed with it. Here I'm reading a 0.3 microhenry coil, and you can see it gives us 0.259 microhenries. It's one of these 4-lead meters, which means each side has got two wires to it to cancel out the effects of the actual probe wire. And I didn't think I'd like these little, these alligator clips, but I got to tell you, I soon changed my mind. I had a big bag of inductors from Dan's Small Parts, and anyway, I never went through them. And when I got this meter, I went through and I got them all sorted out finally. Well, here we're reading a 5 picofarad capacitor, and it's not. It's just one of these cheap 5 picofarad caps, little ceramic cap, and again. Reads low value capacitors exceptionally well. Now this is something I got. I don't know. It's probably over a year ago. It's a GPS disciplined oscillator. It's got a 10 megahertz reference oscillator output, which you can use to plug into the back of your frequency counter or whatever. And then it's got a 1 pulse per second output here. And it comes all, again, it's a Chinese deal, and it comes with a wall wart, and all you have to do is plug in a GPS antenna, which I got from Amazon, and you're good to go. And when it's received the GPS signal and it's locked, then this LED will light up, and you're good to go. Well, I enjoyed that feature, but the only frequency counter I had with that would take an external 10 megahertz input was an old Heathkit frequency counter, which finally started to bite the bullet. So I bought this thing, which is from the same company, and you can see if you plug the reference, 10 megahertz reference plugs into the back, and you can, you'll know it because right here it'll say external reference. It automatically switches between internal and external reference. And I've really enjoyed this little counter. It's just a little, it's a little counter, but it's the most accurate thing I've got right now. This, I think I spent just about $100 for this particular counter, so I thought it was a pretty good value. Now, one of the things I've wanted to do is build a digital VFO, and something that would be fairly accurate. And QRP Labs has had just the ticket for that. In fact, it's built around the same circuit board and SI 5351 oscillator board that's in the QRP transmitter. It basically gives you two outputs. One's a VFO that you use the tuning knob for, and the other is a clock output that you can basically set to anything that you want. It comes with a two-line LCD, but I wanted to display a little more information. I wanted to also see the reference signal and how the reference signal was being affected by the GPS training. Here's the back end. And you can see here, I've got a GPS antenna connection. And this board right here is the QRP Labs GPS receiver. And you take the output and you port it into the main control board here, and that trains things up for you. So you have you have essentially a GPS disciplined oscillator. Whoops. And I really have enjoyed using the VFO side of this. Now, the one thing that you have to do if you're going to use it to use the signal like for a super het mixer or something like that, you have to run it through a low pass filter. And this is where I opted to use that low pass filter board so that I can, for the various ham bands, I can filter the square wave into a sine wave. And finally, Russ mentioned Raspberry Pi. I've been playing with the Pis for a long time, and I got a Raspberry Pi 4. In fact, I've got a couple of them now. The one thing I've never liked about the Raspberry Pi is the fact that you've got connectors coming out of two sides. Well, I just happened on this this case for Raspberry Pi, and what's kind of neat is that it runs all of the outputs to the back end. So here's the back end of it. And the way they do that is they basically take a little daughter board right here that plugs into the sides. So here's your power and audio and your two HDMI connectors. And of course, here's the Raspberry Pi. There's a fan right about here that you don't see. And it has a little magnetic cover that exposes the GPIO connectors. And actually, kind of a neat case, $25. I think I paid for it. And then I thought, well, you know, I always wanted to try hooking up a larger memory or hard drive to it. And so I got one of these M.2 solid state drives. This one's got a no-name card in it. It's 128 gigabyte. And I loaded up Ubuntu Groovy on it. And it works pretty well. You can set the Pi to boot to an external USB device using the Raspi config utility, and then that writes to the EEPROM on your Raspberry Pi. So even after you take your SD card out, you can boot up from whatever system is coming into the USB on the back. So I've tried a number of different operating systems, and the Ubuntu Groovy or 20.10 is a full 64-bit versus the Raspbian, which is 32-bit. But the bad news is it's still Linux. So anyway, and then I just wanted to show Russ this. I put your project, Russ, in a little better case than I initially had, and I really enjoyed this, especially setting the power levels for my VFO. And guys, that's all I got, unless you have any questions.
Well, I came in at the end.
Thank you, Steve.
You're welcome. Shall I stop this then?
Yeah, go right ahead.